Okay, so like I said, you're going to use examples 1 and example 2 in the lesson to help you be able to do some of the homework. I'm going to do some practice with you of the problems of the type where you have to determine is the equation representing a linear equation or not, okay? So we have some rules we have to follow to determine if it's linear or not. You're not going to want to have to graph them all the time to determine it, or find a table of ordered pairs so you can see if there's a constant change in both the x's and the y's. We can look at it just like by eyeballing and say, if it passes all of these tests, then it's going to be considered linear. So, an equation is linear if x and y both have exponents of 1. They're both to the first power. So no x squareds, no x to the third power, no y squareds. It needs to be x and y. Because when we have just an x or just a y, what power is it being taken to? What's the invisible power? The first power. We don't write, like the number 10 has a power. What's its power? 10 to the first power. We just don't write it. The only time we don't have to write the power of 1. So if x and y both have exponents of 1, if x and y are not being multiplied together in that equation, then all is well. It might possibly be linear then. And then the other tests are x and y do not appear in denominators. So if there's any fractions in the problem, and your x or your y, or both, doesn't matter, if any of them, either of them, are in a denominator, it's no longer linear. If they appear in an exponent, not saying the exponent is 1, but if instead the exponent is x or y, like 2 to the x power, or 3 to the y plus 1 power. If they're up in an exponent, that creates a whole different kind of a line, or a graph, I mean, not a line. And the last one, or if they appear in radical signs. What's a radical sign? What's a radical sign? That's not what it is, Mackenzie. How about this? Does that look familiar? Yeah. That's a radical sign. Finding the root of something. In that case, that says find the square root of something. If it's underneath one of those radical signs, an x or a y, then it's not linear. So this is the test you run an equation through. Without graphing it, without finding ordered pairs, you can determine if it's linear or not. Well, if it is a linear equation, we're going to learn our first form of a linear equation called standard form. And standard form looks like this. Capital A, little x. Important that you follow this. Capital A, little x, plus capital B, little y, equals capital C. So ax plus by equals c. A being the coefficient, how many x's are there? B being a coefficient, how many y's are there? C being a constant without a variable attached to it. Where both A and B are not 0. So in other words, if A was 0 and B was 0, the x's would be wiped out, so would the y's be wiped out. We would no longer have a linear equation. One of them can be 0, but they can't both be in the same equation, okay? So sometimes it's useful to have a linear equation in standard form, so we're going to learn right away how to put it into standard form if it is linear. So here's our directions, and this is what will happen in your homework also. If linear, write in standard form and identify A, B, and C. So first of all, we run it through the test. Is this linear? Does it flunk any of the tests? Are x and y to the first power, both of them? Yes. Yeah, there's an invisible power of 1 on both of those. Are they being multiplied by each other? No. No. Any x's or y's in a denominator? In an exponent? Under a radical sign? Okay, then it's linear. Is linear. All you have to do is run it through those tests. Well then, if it is linear, if you can say it is linear, now they want you to put it in standard form and identify those A, B, and C. So, what kind of gives it away that whether an equation, a linear equation is already in standard form? What would be a giveaway? Dylan?
Since it's 5x minus 2y, that would be ax plus by.
Carson, you want to help out?
Those constants on the right side.
So, and the constant doesn't necessarily have to be on the right side, but it has to be by itself. And the x's and y's have to be together on one side. So if the x's and y's are together on one side and the constant is on the other side, you can say it's already really in standard form. So the only thing that's different about this that doesn't look exactly like ax plus by is it doesn't have addition. But can we change that to addition?
Yeah.
What would it be? Plus
Negatives.
negative 2y. And now we'll identify our A, our B, and our C. What's our A? 5. B? Negative 2. So that equation was really already in standard form. It just had been cleaned up. We didn't have the plus minus going on. It had been cleaned up. So we could have just identified right away from it saying that subtraction sign makes that 2 negative. So we have a negative 2 for B and our C is negative 3. Okay, questions on that at all? Okay, in number 2, first of all, let's make that first decision, is it linear or not? No. It's not. Why not?
Because the constant's not
Well, that has to do with standard form. Is it linear? Okay, which rule does it not pass the test? Is x or y in a denominator? There is a denominator, but are x or y in it? No. Well, then it passes that test. Are x and
y
y
is being multiplied.
by what? By x? Oh, but who can't it be multiplied by? X. Is it being multiplied by x?
No, it is linear.
What?
Oh, that's
Yeah, linear. It is linear. It passes every test. It didn't say there couldn't be any fractions in the problem. It didn't say that the x and the y can't be on the same side. The rules, we stated them up above. It passed every test of the rules up above. So now what we're going to do is we're going to get it into standard form because it is linear. So now what could we do to get this in standard form? Well, one of the things I want to share with you is typically, and you need to just know how to do this right away from the beginning, they do not want A values especially, but typically A and B values to be fractions. So right now, x over 2 could be rewritten as 1/2 x. So then A would be a 1/2, wouldn't it? So we don't want it to be that. So the first thing we're going to do is we're going to get rid of fractions. What could we do to eliminate the fraction in this problem? Carson?
Multiply everything by 2.
Multiply everything by 2. Every piece gets multiplied by 2. So let's start there. So what I have in parentheses are the original parts of the equation, and every piece of the equation is getting multiplied by 2. So now we have what? What's our equation read now? Okay. So these 2's cancel. That was our goal. Okay, now we don't have any fractions. Now life is better. Now what are we going to do? We need x's and y's together on the same side. Subtract x from both sides. Can we do that? We need the x's over with the y's. They're not like terms. Could this be rearranged? How could it be rearranged?
That is x plus y.
Now does it look like ax plus by equals c? Okay. So a equals -1, b equals 8, c equals 10. Okay, now, here's another thing that, for some reason, math books and math people just like to not have, not only do they not want fractions for their A and B values, but they don't want negative values for A if they don't have to have them. So if this answer, let's say this was not the way, it wasn't an answer bank, this was on a test and multiple choice answers were there, and you're like, I know I did everything right, why isn't this answer here? Well, maybe they instead said, let's move the y's over with the x's and move the 10 over to the other side. Because remember I said it doesn't matter which side that constant's by itself on. So if instead we subtracted 10 first and had 8y minus 10 equals x, now we would subtract 8y from both sides. And we would have negative 10, a constant, and we would have x take away 8y, which changes things up a little bit in the ABC department too, doesn't it?
Yes.
So now we would say, well, this really can be rearranged like this, if you really want to see it in ax plus by form. It would be x plus negative 8y equals negative 10. A equals 1, B equals negative 8, and C equals negative 10. So notice what happened. What actually happened? The equation has a different look, it has a different name, but what else? What happened to the A, B, and the C? So they all became the opposite of what we got before, didn't they?
Yeah.
They're all the opposites of it. So sometimes we just have to know that there's a different way to rename the equation. I shouldn't say solve it, rename that equation. So we may, I'm going to try and be fairly lenient with you while you're learning how to put it in standard form to start with. But eventually you have to be able to pick from an answer bank the correct answer. If the one you got isn't there, don't just be like, well, this one looks close, I'll just go for it. I want it to be a little bit more legitimate than that. So questions? Where did I leave you behind? Okay, let's go to the back side and practice just a few more and then we'll be done. Okay, first decision, linear or not?
Yes.
Does it pass every test?
Yes.
X and Y are to the first power? Are they being multiplied by each other, x and y? Any x or y in the denominator? Any x or y in a exponent? Any x or y under a radical sign? Sounds to me like it's linear. Well, if it's linear, then they want us to write it into standard form today. So, what do we have here? This fraction set equal to another fraction. This ratio set equal to another ratio. What's that called? Well, you're getting ahead of me here, Chris. What's this called? Starts with a P. Proportion. This is a proportion. And I said, now that you're big ninth graders, you get to do what with proportions? Cross products. You get to do those cross products that say multiply numerator and opposite denominators times each other. So we're going to have 5 times x minus 2. And you might as well just do it so that your x ends up on the left side right away. That's kind of handy. Notice I put x minus 2 in parentheses because that denominator has to be multiplied by that numerator. Both pieces are part of that numerator, so we have to use those parentheses. So now we have our problem set up, and now we can simplify, and then rearrange to get standard form. What do you want to make the first move after we've simplified it here? Subtract something? Add something?
Add 10 to both sides.
Yeah, let's get the constant over on the right side, so then we'll move the y's over with the x's, right? So we'll add 10 to both sides. That would be probably a good choice to make anyway. 5x equals 3y plus what? 13. Okay. What would our next move be? Subtract 3y from both sides. Get those y's over with the x's. Because standard form says they want to be together on the same side. In standard form? Well, kind of, it's in cleaned up standard form, right? Let's see if we can identify the A, B, and C without, renaming it and getting it back to its not cleaned up state. What would A be?
5.
What about B? Negative 3, because this subtraction makes that 3 negative, and C is 13. Okay. So I just see this much work when you're doing these in your homework. Don't just claim it is linear, standard form, somehow you just magically have this new name for the equation and your A, B, and C. How about number 4? Is it linear?
No.
What's the problem?
X and Y are being
Okay, so we're going to say is not linear, and if it's not linear, we're not going to talk about standard form. We're going to say x and y, we're going to give our reasoning why it is not linear, are being multiplied. That's the rule of Brooke. Give your reasoning. Maybe it's because it's in the denominator. Maybe it's because the x is being taken to a power other than 1. Whatever the rule is that breaks. Okay, how about number 5? Is that linear? Any rules it breaks? No?
So,
Is there anything in the rules that say if there's no y's? No. But it's linear, isn't it?
Yes.
Yep, it's linear. If it is linear, then we're going to talk about standard form and A, B, and C. So what do we have to do to this? Get it in standard form.
It is.
It is in standard form. It is in standard form already. The constant's all by itself over there. The x's are over here. There are no y's to join them. If there are no y's, that means what?
0.
What's 0?
Y.
B is 0. So this is in standard form already. Make that note in our notes so that we realize we did not have to do anything to it. And if you're not convinced, you could do this. You could basically, what I call unclean it up. You could write it like that. Because 0 times y is what? 0. And 0 plus 4x is what? 4x, yeah. So what's our A value? 4. Our B value?
0.
0. And our C value?
-8.
-8. Okay. So what did it say back in the beginning of the notes where A and B are both not 0? If one of them can be, but they both can't be. So A can be 0 or B can be 0, but not both. Okay, any questions? Okay, then let's get going on that homework. You know now we talked about what kind of work you have to show for the ones we didn't practice together. We will also give you examples to help you. Example 1 and example 2. And then these types of problems, that's what I practice these with you for.